Welcome back, everybody, to another deep dive into science.
Hey there.
Today, we're looking at turning pollution into power.
Whoa.
Pretty cool, huh?
Yeah, definitely. That's a catchy way to put it.
We're going to be talking about how scientists are using electrochemistry
Okay.
to transform co-emissions. You know, that stuff we're always talking about, reducing
Yeah.
fuel.
It's a pretty fascinating area of research.
What is it?
It's really like a fusion of environmental chemistry and renewable energy technology.
Oh, wow.
So we're not just thinking about as a waste product.
Right.
We're actually thinking about it as a potential building block for something useful.
Okay, so
Yeah.
how does turning code into fuel actually work?
Well,
I mean, is that like some magic machine or something?
not magic,
Okay.
but it is pretty ingenious.
Aye.
It all happens within electrochemical cells.
Okay.
So imagine like a setup where you're using electricity
Yeah.
to drive a chemical reaction
Okay.
that converts CO into other valuable products. Like the fuels that we use every day.
You're saying we could potentially power our cars with something derived from the emissions they produce?
Yeah.
That's crazy.
It is a mind-bending concept.
It really is.
But the key to making this process efficient and selective lies in something we've talked about before.
Okay.
Catalysts.
Yes.
Remember those?
Catalysts are chemical matchmakers.
Yes, exactly.
What we talked about in one of our other deep dives. So those synthetic MARVAs.
Yeah, that sounds right.
So they speed up reactions?
Right.
Is that what they do?
Exactly.
Okay.
So in the case of CO reduction, catalysts are crucial for ensuring that we get the fuel products we want and not a bunch of unwanted byproducts.
Yeah, okay.
So researchers are actually exploring all sorts of materials, like metal organic frameworks.
What are those?
They're basically like tiny little scaffolds made of metal, ions, and organic molecules.
Okay.
And they can be designed to be incredibly selective
Wow.
for specific reactions.
So it's like we have a recipe, and the catalyst is like this secret ingredient
Exactly.
that makes sure you bake a perfect cake
Yeah.
and not some like crumbly mess.
Yeah, that's a great analogy.
Okay, cool.
So just like a skilled baker can adjust their recipe to create different cakes.
Right.
Scientists can design catalysts that steer the CO reduction process to yield specific fuels.
Okay.
So for example, they can create catalysts that are really good at producing methanol.
Oh, wow.
Which can be used in fuel cells.
Oh, that's really cool. It makes me think about fuel cells and like the practical applications of this whole thing.
Yeah.
I mean, it's one thing to make fuel in a lab.
Yeah.
But how realistic is it to like scale this up to meet our energy needs, you know?
That's the million-dollar question.
Yeah.
And that's actually where a lot of the research is currently focused.
Okay.
You know, scaling up any process from a lab to an industrial level is a huge undertaking.
Yeah.
Think about it. Like, you're trying to replicate the success of a small artisanal bakery on a mass production scale.
Yeah.
It's not easy.
So what are some of the biggest hurdles researchers are facing in terms of making this technology scalable and commercially viable?
One of the major challenges is energy efficiency.
Okay.
So right now, the process can be quite energy intensive. And if we're not careful, we could end up using more energy to create the fuel than we get out of it.
Right.
Which would kind of defeat the purpose.
Yeah, that makes sense.
So it's not as simple as just plugging in a machine and watching it churn out barrels of fuel.
Right.
There's a lot more to it like that.
It's like a complex system.
Yeah, definitely.
With a lot of moving parts.
Exactly. Scientists are working on making the process more efficient by experimenting with different reactor designs and trying to optimize those reaction conditions.
Oh, okay.
So think of it like fine-tuning a car engine to get the best mileage possible.
Okay, I got it.
Yeah.
So it sounds like this technology is still in its early stages.
It is.
But the potential benefits are pretty incredible.
Absolutely.
If we can figure out how to turn CO, which is essentially a waste product, into a valuable fuel source.
Right.
I mean, that would be a game changer in terms of fighting climate change.
Yeah, definitely.
And just creating a more sustainable future in general.
Yeah, it's a prime example of how science can tackle multiple challenges simultaneously. So we can potentially reduce those harmful emissions while also generating the fuel we need to power our world.
Exactly.
It's pretty exciting.
It is.
You know, it's fascinating to think that the same principles driving this CO transformation could be applied in other areas too.
Really?
Like scientists are taking inspiration from one field and applying it to another.
That's interesting.
Yeah.
What other areas are we talking about here?
Well, for instance, researchers are looking at how electrochemical processes, similar to the ones we've been discussing, can be used to break down harmful toxins.
Oh, wow.
Think of it as a way of turning pollutants into something less harmful.
So you're telling me we could use a similar approach to like tackle things like toxic waste?
Exactly. It's a whole other level of problem solving.
It is.
So just like we can use catalysts to guide the sewer reduction process, we can design catalysts that help break down toxins into less dangerous compounds.
So instead of having these harmful substances just hanging around causing problems, we can essentially neutralize them using this technology.
In many cases, yes.
Wow.
And the beauty of it is that these electrochemical methods can be more environmentally friendly than traditional methods of dealing with toxins.
So it's like we're opting for a gentler, more targeted approach?
Exactly.
Rather than just using harsh chemicals or really energy-intensive processes.
Exactly.
This reminds me of when we did our deep dive on toxins used as neuroscience tools.
Oh, yeah.
It's amazing how something that can be so harmful can also be so valuable in a different context.
It really all comes down to understanding the underlying chemistry and finding ways to manipulate it to our advantage.
So if we could use this approach to address toxins, are there any, like, limitations?
Well,
can we tackle any type of toxic waste with this?
Well, the potential is huge. There are definitely limitations. Some toxins are more resistant to this kind of breakdown just because of their complex structure or inherent stability. Just like trying to disassemble a sturdy, well-built structure versus something that's more fragile.
So it's not a one-size-fits-all solution.
Right.
But it could be a really powerful tool for tackling these environmental challenges.
Exactly. And the more we understand these processes, the better equipped we'll be to address a wider range of pollutants in the future.
That makes sense.
It's all about pushing the boundaries of what's possible.
I'm curious about the economic side of things. We talked about the energy efficiency challenges. But how cost-effective is this technology compared to traditional fuel production?
That's a key question, and honestly, it's one of the biggest hurdles right now. Electrochemical CO reduction is still relatively expensive compared to fossil fuel-based methods.
So it's not quite ready to compete on a large scale?
Not yet, but researchers are working hard to bring down that cost. One promising avenue is the development of cheaper and more durable catalysts. Just like with any new technology, the initial costs are often high. But as research progresses and production scales up, those costs tend to decrease. Think about the early days of solar panels. They were incredibly expensive, but now they're becoming more and more affordable.
So there's hope that we can make this technology commercially viable.
Absolutely. It's a matter of ongoing innovation and investment. The potential benefits are enormous, both for the environment and the economy. Imagine a future where we can create clean, sustainable fuel from a readily available source like SOO. That's a goal worth striving for.
It's like turning a liability into an asset.
Exactly.
Instead of viewing co-emissions as a problem. We could see them as a valuable resource.
Precisely, and that shift in perspective could be revolutionary.
You know, one thing that strikes me is how this technology is blurring the lines between different scientific disciplines.
It is.
We're talking about chemistry, environmental science, engineering, even economics.
It's a truly interdisciplinary field.
Yeah, it is.
And that's what makes it so exciting. It requires collaboration and innovation across multiple fields to make real progress.
Like a team of experts coming together to solve a complex puzzle.
Exactly.
And it sounds like the pieces of that puzzle are starting to fall into place.
They are. The pace of research is accelerating.
That's good.
And I'm confident that we'll continue to see breakthroughs
awesome
in the years to come.
Well, before we get too far ahead of ourselves, let's take a step back and consider some of the broader implications of this technology. If it does become widely adopted, how might it change the world as we know it?
That's a great point. The potential societal impacts are significant and worth exploring. So let's delve into those in our next segment.
All right, so we've been talking about turning co-emissions into fuel. And it seems like the science is pretty groundbreaking. But I'm thinking about, like, the ripple effects, you know, how this could actually change the world if it takes off.
That's a crucial aspect to consider. Any technology with this much potential is bound to have a significant impact on society.
For sure.
It's like dropping a pebble in a pond and watching the ripples spread outward.
So where do you see those ripples going?
Well,
what kind of changes might we expect?
Okay, so for starters, It could lead to a major shift in global energy dynamics.
Okay.
Imagine a world where we're no longer solely reliant on fossil fuels.
Wow.
Where countries can generate clean energy from CO.
Yeah, that would be huge.
Right.
That makes me think about all those countries that have traditionally held a lot of power because of their oil reserves.
Right.
This could really shake things up.
It definitely has the potential. And it's not just about the geopolitics.
Right.
There's the economic side, too.
Of course, yeah.
Think about the job market.
Okay.
We might see a decline in traditional fossil fuel industries.
Right.
But at the same time, a surge in new jobs.
Oh, wow.
Related to this new technology.
So it's like a transition. One energy landscape to another, and we need people to design and build and maintain all these systems.
Exactly. It would require a whole new workforce skilled in this specific technology.
Okay.
It's kind of like the rise of the computer industry.
Oh, yeah.
Back in the day, created a whole bunch of new jobs and opportunities.
So beyond the economic implications, what about the environment?
Okay.
I mean, we've talked about reducing emissions, but are there any downsides?
That's a valid concern. I mean, while the goal is to create a more sustainable future, we need to be mindful of any unintended consequences.
Okay, so what could those be?
Well, for example, even though we're reducing co-emissions, the process itself still requires energy.
Oh, right. Okay.
So the source of that energy really matters.
So we wouldn't want to solve one problem just to create another.
Exactly.
Yeah, we need to make sure the energy is clean and renewable.
It all ties back to that bigger picture of creating a truly sustainable energy ecosystem.
It's also interesting to think about how this might influence consumer behavior.
Oh, yeah, for sure.
I mean, right now, we're so used to filling our cars with gasoline.
Right.
How might that change?
Well,
if we can create fuel from CO.
It could lead to some interesting shifts.
Oh, okay.
Imagine if you could choose between gasoline or a fuel made from captured CO.
Right.
It could spark a whole new wave of eco-conscious consumerism.
It's like giving people a more tangible way
to
be involved in the fight against climate change.
Exactly.
So instead of just reducing their own footprint, they're actually contributing to clean fuel.
That's a great point.
Yeah.
It could empower people to make more sustainable choices.
Right.
And feel like they're a part of the solution.
As we wrap up this deep dive, I'm feeling a mix of excitement and cautious optimism.
I agree.
The potential benefits of this technology are truly remarkable. But we need to be aware of the challenges and potential pitfalls.
It's crucial to approach this technology with a balanced perspective,
right,
acknowledging both its promise and the need for careful consideration of its broader impacts.
Well, I think this has been a really insightful exploration
of
electrochemical CO reduction.
Yeah.
It's clear that this technology has the potential to reshape our world.
Absolutely.
In some really profound ways.
It really does.
And I'm eager to see what the future holds.
I am too. It's a testament to human ingenuity and our ability to find innovative solutions to the challenges facing our planet.
Absolutely.
If we can harness the power of this technology responsibly, it could pave the way for a more sustainable future.
That's what we're all hoping for.
For everyone.
Thanks for joining us on this deep dive.
Thanks for having me.
We hope you learned something new and are as excited as we are about the possibilities of this game-changing technology.
Pretty amazing.
Until next time, keep exploring 24.